morning, student. I am Venkataya, Assistant Professor of Vigyanas Lara Institute of Technology. So now I am going to teach the subject is the thermal and hydro prime movers. That is the fourth unit. So this is the contents of impulse momentum equation. In the previous class, I have discussed the impulse momentum equation, impact of jets on a stationary and moving winds. That is the flat and curved. As well as the pumps, we know that the pumps and that is the different types of pumps is there. So I will explain in after completion of this class. I will explain the problems of impact of jets and that is the momentum equation, as well as the curved plates and flat plates, then the inclined plates. After completion of that one, I will explain the pumps. Okay. So in this class, I have discussed the impulse momentum equation, impact of jets and stationary and moving winds. So some of the in the previous class continuation of these topics. Okay. So this is the force applied by the jet of water on the fixed curved plate. Okay, on the fixed curved plate. So we have taken here is that is the fixed curved plate. So the curve is nothing but here. This is the thing. Okay. So in this fixed curved plate, we have to. I will explain clearly. Okay. In this is the support fixed. That is nothing but the fixed is nothing but the support, and we have to see here. Here also, okay, in this direction, this is the x direction, okay, then we have to take, here is, that is the vertical, that is the v sine theta, okay, v sine theta, and this one is the v cos theta, and the angle between the vertical and the horizontal, that is the velocity of v, and the angle between the horizontal and the vertical is theta. Okay, then here also we have to draw is the v sine theta. This is the v cos theta. Okay, so this is the thing. So fixed curved plate in the sense of we have to fixed in the support. We have this is the we have to support, that is the we can write here is this only. So when the jet strikes at the end of the plane, this is the symmetrical. Okay, in the previous class, that is the vertical previous class curved plate is there. So but this is the symmetrical of a curved plate. Okay, of curved plate. So this is the, we have to see, this is the direction of x and the direction of y. So we can write here is this point is end point, and this point is also one of the end point. That one is we have taken that value of in x direction. X direction we have to take the v cos theta, and the y direction we have to take v sin theta. Okay. Then we have to. So here thing is. So in this force applied by the jet of water on the fixed curved plate, that is the when the jet strike at one end of the plate is symmetrical. So one end of the plate is here is symmetrical, one end of the plate is symmetrical. Then we can write is this is the y direction, this is the y direction v sin theta, and the x direction so v cos theta. Then the angle between the x direction and the y direction theta, that is the velocity. Okay, and this one is the fixed end, one end, and this is the fixed another end of curved plate of symmetrical, so that the value of fx, that is the forces, so forces in x direction, so forces in x direction, so fx equal to mass into acceleration, m into a. So mass we can call it as density, density into area into acceleration, that is the velocity, into v cos theta minus of minus v cos theta. Then we can write it as rho a, so 2 rho a v square into cos square theta, because of cos into cos square theta. Then the y direction, so fy, then the y direction, so we have to take the y direction. So y direction in the sense of v sin theta. So in the x direction, we have to take in the v cos theta. Okay, this is the important v cos theta. Then the y direction we have to take v sin theta. Is it clear? So then the rho a v into v sin theta minus v sin theta. So here v sin theta, v sin theta. So fy equal to rho a v into 0. So fy equal to 0. That is the 0 value. Okay, is it clear? And here the force applied by the jet of water on the fixed curved plate. So and the fixed curved plate, so we have to see here, this is also already explained in the previous slide, so I will explain again. So this is the fixed curve. Okay, this is the one end of fixed plate. Then it is the y direction, that is the v sin theta, and this is the v cos theta. Okay, the angle between the y direction and the x direction is the phi or theta. Okay, this is the x horizontal direction, and this is also v cos theta and v sin theta. Okay, then the finally, so the fx direction equal to mass into acceleration. Okay, mass into acceleration. Then the value of rho av, mass means we know that the rho av into v cos theta minus v cos theta. Then finally we get the rho av square cos theta plus cos phi. Okay, here we are taking the pi value. That's why here pi. Okay, then Fy equal to, so mass into acceleration, that is the mass rho av into v sin theta minus v sin pi. We have to remember this formulas. It is a very important formulas. Okay, you have to remember this formulas, because of when we are doing the problems, it is a very important. Okay. Then, so force applied by the jet of water on a moving curved plate. Okay, on moving curved plate. This is not a fixed. So in the previous slide, that is fixed plate of curved plane. Okay, here this is not a fixed. Okay, this is the force applied by the jet of water on moving curved plate. Okay, on moving curved plate. That is so moving curved plate is nothing but here we have to write it is. Okay, this is the x direction. Okay, so here this is the y direction, v minus u sine theta. So v means initial velocity minus final velocity. Okay, this is the x direction, that is the v minus u cos theta, and the angle between the vertical and the horizontal, that is the theta. Okay, the force is, velocity is initial minus final. Okay, here also v minus u cos theta, and here v minus u sin theta. Okay, so this is the fixed vanes. And the force applied by the jet of water on the moving curved plate, that is the Fx, x direction. So mass into acceleration, then the density into acceleration, ma, rho into a into initial velocity minus final velocity into v minus u cos theta. Okay, cos theta minus of minus v minus u cos theta. Okay, then v minus u. Okay, so v minus u into v minus u whole square, that is the 2 rho a Fx equal to 2 rho a v minus u whole square cos theta. Okay, then the y direction, this is the only for x direction. Okay, so 2 rho a into v minus u whole square into cos theta. So here the y direction, mass into acceleration, that is the rho into v minus u whole square into v minus u sin theta, minus of v minus u sin theta. Okay, then v minus u sin theta, then v minus u sin theta, it will be cancelled. Then finally rho a into v minus u whole square into 0, then finally we get the 0 in Fy direction. Okay, is it clear? So actually we see here the previous classes, this is the impulse momentum equation. So here the impulse momentum equation is clear. Okay, and the impact of jets on stationary and moving vanes, flat and curved. Okay, so flat and curved plates is also completed. Okay, and coming to the next class, I have discussed the problems of impulse momentum equation. Okay, so that is the impulse momentum equation, and here see here, it is the symmetrical figure of curved plate. Okay, is I already explained in the previous slide. So that is the thing, and in this class what I have discussed is curved plates as well as the fixed plates. Okay, then the inclined plates. Okay, thank you.